Hello and welcome. In this tutorial, we're going to build a fully interactive Excel dashboard from scratch. The best part? No VBA, no macros, no form controls. We'll use only Excel's built-in features, including some if, filter, count, let, lambda, and data validation drop-down lists. By the end of this tutorial, you'll have a professional dashboard that updates instantly whenever a user selects a different option from a drop-down menu. Here's a quick preview of the finished dashboard. Notice that the first row stays visible while scrolling. I've frozen the top row, so the 3 drop-down menus always remain on the screen. Those drop-down menus control the entire dashboard. They update the KPI cards, charts, and summary tables automatically, allowing you to analyze your data by different criteria with just a few clicks. If your manager ever asks you, "Can you show me sales by region? Which products sold the most? What happened this quarter?" This is exactly the kind of dashboard that makes you look like an Excel expert. So, let's get started. Our worksheet contains raw sales data. Each row represents one customer order, and each column stores a different piece of information, including order date, location, salesperson, category, product, units, sales, profit. The very first thing we'll do is convert our data into an Excel table. If you're planning to build dashboards in Excel, this is one habit you should always develop. To quickly create a table, simply select your data and press Ctrl-T. You can also go to the Home tab, click Format as Table, and pick any style you like from the gallery. Excel will display the Create Table dialog box, where you can confirm the data range for your table. You'll also see My Table has Headers checkbox. If your data includes column headings, make sure this option is checked so Excel recognizes the first row as the table headers. Next, go to the Table Design tab and give your table a meaningful name. I'll name mine Data Table. Always use descriptive table names instead of the default names like Table 1 or Table 2. As your workbook grows, meaningful names make your formulas easier to read, understand, and maintain. Next, rename this worksheet to Data. Giving worksheets meaningful names makes navigation much easier, especially in large workbooks. Now insert a new worksheet. Rename it to Dashboard, and this is where we'll build our interactive dashboard. Now we're ready to design the dashboard. In cell A2, type Dashboard. We'll intentionally leave row 1 empty. Later, this row will hold our interactive drop-down menus, and we'll freeze it so the filters always stay visible while scrolling. Now select cells A2 through S2. Go to the Home tab. In the Alignment group, click the small dialog box launcher in the bottom right corner. In the Format Cells dialog box, change Horizontal Alignment to Center Across Selection, and click OK. Notice that the title appears perfectly centered, without merging any cells. That's important. Unlike Merge and Center, Center Across Selection keeps every cell independent, making future editing much easier. Most experienced Excel users avoid Merge and Center because it often causes sorting, filtering, copying, and formula problems. Next, apply a background color that matches your dashboard theme. I'm using a dark background with white text for better contrast. I've also changed the font to Bond Schrift semi-bold and increased the font size to 20. Dashboards usually look much cleaner without grid lines. To remove them, I'm first selecting the entire worksheet by clicking the Select All button at the intersection of the row and column headings. Next, I'll apply a white fill color to all the cells. Because the cells now have a background fill, Excel automatically hides the grid lines. Another way to do this is to go to the View tab and clear the grid lines checkbox. Before moving on, press Ctrl-S and save your workbook. Give it a meaningful name, such as Interactive Dashboard.xlsx. Saving frequently is a good habit, especially during larger projects. Now we're ready to create our KPI cards. Our dashboard will begin with 4 KPI cards. KPI stands for Key Performance Indicator. A KPI card is a compact visual element that highlights an important business metric at a glance. These small cards allow decision makers to understand performance within seconds. Let's create our first dashboard card. In cell E4, type units sold. Then, in cell E5, calculate the total units sold by summing the units column from data table using a structured reference. This formula adds all the values in the units column and returns the overall total. At this stage, we're calculating the grand total. Later, when we add drop-down filters, this value will automatically update based on the selected region, product, or month. Next, we'll create our second dashboard card, which will display total sales. In cell H4, type total sales. Then, in cell H5, enter the formula shown on screen. Once again, we're using a structured reference instead of a traditional cell range. This formula adds all the values in the sales column and calculates the total sales for the entire dataset. Now, let's create our third dashboard card for total profit. In cell K4, type total profit. Then, in cell K5, enter the formula shown on the screen. This formula adds all the values in the profit column and calculates the total profit for the entire dataset. Simple for now, but we'll enhance this card shortly by adding profit margin. Finally, let's create our last dashboard card, top salesperson. In cell N4, type top salesperson. For now, leave the value underneath blank. Finding the top performer requires a more advanced formula with multiple functions working together. So we'll come back to this card after completing the simpler KPI calculations. A good strategy when building dashboards is to finish the easy calculations first, then move on to the more complex formulas. Now let's go back to our third card and calculate the profit margin. Under the total profit card, in cell K6, we'll add the profit margin calculation. Profit margin tells us what percentage of our sales has turned into profit. To calculate it, we divide total profit in cell K5 by total sales in cell H5. This returns a decimal value. For example, a result of 0.43 represents a 43% profit margin. Next, we'll format the result as a percentage. This is the recommended Excel approach because the value remains numeric and can still be used in future calculations. However, for this dashboard, we want the card to display something more descriptive like 43% margin. Since we are combining the percentage with text in the same cell, normal cell formatting is no longer suitable. Instead, we'll use the text function to control the display. This converts the percentage into a clean text display while adding the word margin after the value. The result might display something like 43% margin. That's much clearer than showing only 43%. Now let's calculate the number of orders. In our table, each row represents a single order. So, in cell H6, enter the formula shown on the screen. Because the order date column always contains valid dates, we can use the count function to count the number of orders. Why use count instead of rows? Because Excel stores dates as numeric values. The count function only counts cells containing numbers, so any blank rows will be ignored automatically. Finally, to make the dashboard card more meaningful, we'll append the result with the text orders. The result will look something like 250 orders. Now, anyone viewing the dashboard immediately understands what the number represents. Now let's return to our units sold card. In cell E6, we'll calculate the average sales value per order. To calculate this, we divide total sales from cell H5 by the total number of orders. Notice that we're calculating the order count again instead of referencing cell H6. That's because H6 contains text, such as 250 orders. Once text is added to a value, Excel treats the result as text rather than a pure number, so it can no longer be used directly in calculations. The formula returns a decimal value, so we'll use the round function to remove the decimal places. Finally, to make the KPI card more descriptive, we'll combine the result with text. The result will look something like average $718 per order. Now, Anyone viewing the dashboard immediately understands what this number represents. Our KPI calculations are now complete, except for the top salesperson card, which we'll calculate later. Now let's format these KPI cards and transform them into clean, professional-looking dashboard widgets. For the first KPI card, select E4 through F6. Open the Format Cells dialog again, and choose Center Across Selection. Click OK to apply the alignment. Repeat the same process for the remaining cards. Next, increase the font size of each KPI value to around 20 points. Finally, apply a thick outside border to each card. Now, every KPI appears as its own visual widget, giving each metric a clear container and making the dashboard much easier to scan. Now, comes the interesting part. We need to determine which salesperson generated the highest total sales. Rather than jumping straight into a long, complex formula, we'll break the problem into smaller, easier-to-understand steps. We'll start by creating a simple summary table. In cell E9, type the heading, Salesperson. Then, in cell E10, retrieve a list of all salespeople by using the unique function on the Salesperson column. The unique function returns each salesperson only once, automatically removing any duplicates. Because this formula returns multiple values, Excel creates what's called a spill range. In cell F9, type the heading, Sales. Now we'll use the SUMIFS function to calculate the total sales for each salesperson. The SUMIFS function has 3 arguments. The first argument is range. This is the column Excel checks for matching values. Here, we provide the salesperson column from our data table because we want to identify each salesperson. The second argument is criteria. This is the value Excel searches for within the range. Here, we provide our newly generated salesperson list using the spill reference. Notice the hashtag symbol at the end of the reference. This tells Excel to use the entire spill range instead of just a single cell. The third argument is sum range. This is the column containing the values we want to add. In our case, we provide the sales column from the data table. Now Excel checks each salesperson in the data table, matches them against the names in our unique list, and calculates the total sales for each person. Because the criteria argument is a spill range, the SUMIFS formula also returns multiple results automatically. In just a few seconds, we've created a complete sales summary table. Now let's find the highest total sales value. In another cell, enter the max function and point it to the sales spill range. The max function returns the largest value in a range. Now we know the highest sales amount, but we still need to identify the salesperson who achieved it. To do that, we'll use the xmatch function. The first argument is the lookup value. Here, we'll reference the highest sales amount in G10. The second argument is the lookup array, so we'll provide the sales spill range. The xmatch function returns the position of the value from G10 within the sales spill range. For example, if the highest sales value is the second item in the list, xmatch returns 2. This is the position within the spill range, not the worksheet row number. Finally, we'll use that position with the index function to return the matching salesperson from our unique list. The index function returns the value at the specified position. Since xmatch returned 2, index returns the second salesperson in the unique list. In this example, the top salesperson is Kenji. Although this approach works perfectly, it relies on several helper formulas. Let's simplify everything with a single let formula. The let function allows us to store intermediate calculations in variables, making formulas easier to read, understand, and maintain. Here's what the formula does. First, max_sales stores the highest sales value from a sales summary. Next, sales_person uses xmatch to locate that value and index to return the corresponding salesperson from our unique list. Finally, VStack combines the salesperson and their total sales into a single vertical result. The salesperson appears on the first line, and their total sales appear directly underneath. Now we can place this single formula inside our KPI card. Instead of relying on multiple helper formulas, we've combined everything into one clean, dynamic formula that produces exactly the same result. At this point, our KPI cards are complete. Now it's time to make the dashboard interactive. We'll add data validation drop-down lists that allow users to filter the dashboard by region, product, and month, just like using the filter buttons in an Excel table. With a single selection from any drop-down, every KPI, summary table, and chart will update automatically, giving users an interactive dashboard they can explore with just a few clicks. Let's start by creating the first drop-down list for category. As you know, all of our data is stored in a single Excel table on the data sheet, which we name Data Table. First, we'll generate a list of unique categories. In cell I-10, enter the formula shown on screen. The unique function returns every category only once, automatically removing duplicates. Now, let's try using this formula directly in a data validation list. Copy the formula, then go to the Data tab, click Data Validation, choose List, and paste the formula into the source box. When you click OK, Excel displays an error. Why? Because the data validation source box doesn't accept dynamic array formulas such as unique, and it also doesn't support structure references like data table, category. Fortunately, there's an easy workaround. Instead of giving data validation the formula itself, we'll point it to the formula's output. Since the unique formula is already returning its results in cell I-10, and those results form a spill range, we can reference that spill range instead. Now, on the first row of the dashboard sheet, type category where you want the filter label to appear. Select the cell next to it, then open the data validation dialog again. Choose List, and in the source box enter equals I-10 hashtag. Notice the hashtag symbol after the cell reference. It tells Excel to use the entire spill range that starts in I-10. Click OK. Your drop-down list is now populated with all the unique categories. We'll use exactly the same technique for the region and quarter filters. First, we'll generate a unique list for each field, and then we'll use the corresponding spill ranges to create dynamic drop-down lists that automatically expand whenever new data is added. Now let's create our second helper list for quarter. In cell K10, enter the unique function to generate a list of all quarters from the data table. Now go back to the first row of the dashboard sheet and type quarter to the right of the category filter. Select the cell next to it, open the data validation dialog box, choose List, and in the source box enter equals K10 hashtag. The hashtag tells Excel to use the entire spill range starting at K10. Click OK. Our second dynamic drop-down list is now ready. You might be wondering why we're using formulas instead of simply typing the list manually. The reason is simple: automation. Whenever new records are added, existing records are removed, or the data changes in any way, the unique formula updates the list automatically. That means our drop-down list always stays up to date without any manual maintenance. Finally, let's create our last helper list for region. In cell M10, use the unique function to generate a list of all regions from the data table. Then, on the first row of the dashboard sheet, type region to the right of the quarter filter. Select the cell next to it, open the data validation dialog box, choose List, and in the source box enter equals M10 hashtag. Click OK. Our third and final dynamic drop-down list is now ready. At the moment, these drop-down lists aren't filtering anything. They're simply displaying the available categories, quarters, and regions from the data table. We'll now connect these drop-down lists to our formulas so that every KPI card, summary table, and chart responds automatically to the selected filters. Before we do that, let's improve the appearance of our dashboard. Apply a black fill color and white font color to the first row to make the filter area stand out from the rest of the dashboard. Next, we'll freeze the top row. Go to the View tab, open the Freeze Panes drop-down, and choose Freeze Top Row. Now, the row containing our filter drop-down lists remains visible at the top of the worksheet, even as we scroll. This makes the dashboard much more user-friendly because the filters are always within reach. You can change a filter at any time and immediately see the updated KPIs, tables, and charts without having to scroll back to the top. Now it's time to make these drop-down lists actually filter our dashboard. Let's start with the units sold card, which currently sums every value in the units column of the data table. To make it respond to our filters, we'll replace the sum function with SUMIFS. The syntax of SUMIFS is straightforward. The first argument is the sum range, the column containing the values you want to add. For our units sold card, this is the units column from the data table. After that, we add criteria range and criteria pairs for each condition we want to apply. You can add as many criteria pairs as needed. For our first condition, the criteria range is the quarter column from the data table, and the criteria is the selected value from the quarter drop-down list in cell H1. Whenever the user selects a different quarter, SUMIFS compares every row in the quarter column with the selected value and includes only the matching rows in the total. We'll repeat the same pattern for the category and region filters, allowing all three drop-down lists to work together to produce a fully dynamic result. Now, let's connect the category drop-down to our SUMIFS formula. We'll add another criteria range and criteria pair. For the criteria range, select the category column from the data table. For the criteria, reference the selected value from the category drop-down list in cell K1. Now, our formula is connected to two filters, quarter and category. Excel checks every row in the data table against both conditions and includes only the rows that match the selected values. So, whenever the user changes the selected quarter or category, SUMIFS automatically recalculates the result using the new filter selections. Notice that if we remove a value from any of the drop-down lists, such as quarter or category, the SUMIFS formula returns 0. We'll fix this behavior after adding our third condition for the region filter. Now, repeat the same process by adding another criteria range and criteria pair. This time, the criteria range is the region column from the data table, and the criteria is the selected value from the region drop-down list in cell N1. Now all three filters are connected. Whenever the user changes any of these selections, SUMIFS checks every row in the quarter, category, and region columns against the selected values and includes only the rows that match all three conditions in the total. Now let's fix the 0 result returned by SUMIFS when one of our drop-down filters is blank. Currently, cells H1, K1, and N1 are being used as criteria. When any of these cells is blank, SUMIFS treats that blank cell as a condition and tries to find matching blank values in the corresponding column. Because our quarter, category, and region columns in data table do not contain blank values, there are no matching rows, so the result becomes 0. But we also want our dashboard to be flexible. Sometimes we don't want to apply every filter. For example, we may want to view all quarters or filter only by category while leaving the other filters open. To handle this, we'll use a wildcard character, the asterisk. In SUMIFS, when asterisk is used as a criteria for a text column, it matches any text value. This effectively allows us to bypass that particular condition. So, instead of directly using the value from H1 as the quarter criteria, we'll add an if condition. We'll check whether H1 is blank. If H1 is blank, return asterisk so the quarter condition is ignored. Otherwise, return the value from H1 and apply the selected quarter filter. Now let's test it. Delete the value from the quarter dropdown. Instead of returning 0, the formula now ignores the quarter condition and applies only the remaining filters, category, and region. Now we'll apply the same logic to the other two filters. Replace the category criteria with an if function that returns asterisk when a category dropdown in K1 is blank. Otherwise, it returns the selected category. Do the same for the region criteria by replacing N1 with another if function that returns asterisk when the region dropdown is blank. Otherwise, it returns the selected region. Now, let's test the formula. Clear the values from all three dropdown lists so they're blank. Notice that the formula no longer returns 0. Instead, because each blank filter is replaced with asterisk, SUMIFS doesn't restrict the results by quarter, category, or region. It matches all text values in those columns and returns the total for the entire units column in the data table. Let's make our filters even more user-friendly by adding an all option to each drop-down list. This gives users complete control over the dashboard. They can filter by a specific quarter, category, or region, or choose all to include every value for that filter. To do this, we'll edit the helper lists that populate our data validation dropdowns. Let's start with the quarter list. At the moment, it uses the unique function to return all available quarters. Since the dropdown is linked to this spill range, we simply need to add all to the beginning of the list. We'll wrap the existing unique formula inside the stack function and make all the first item. Now the helper list starts with all, followed by every unique quarter. Repeat the same process for the category and region helper lists. Notice that all now appears in each helper list. Because our data validation dropdowns are linked to these spill ranges, the all option automatically appears in the dropdown menus as well. Now let's test it. Select all from one of the dropdown lists. Notice that our SUMIFS formula returns 0 again. That's because SUMIFS is trying to find rows containing the text all in the corresponding column. Since no row contains the value all, there are no matches, so the result is 0. To fix this, we'll make one small change to the if expression we added earlier. Currently, our formula checks whether the dropdown is blank. Instead, we'll use the OR function to check two conditions. Is the dropdown blank? Or is the selected value all? If either condition is true, the if function returns asterisk, which causes SUMIFS to match every text value in that column. If neither condition is true, the formula returns the selected value from the dropdown and applies that filter as usual. Now test the dashboard again. When you select all, that filter is ignored, while the remaining filters continue to work normally. Apply the same change to the category and region criteria. Now test the dashboard again. We can now filter by any combination of quarter, category, and region, or choose all to include every value. Now copy this formula and go to cell E5, the units sold KPI card. Replace the existing SUM formula with this new SUMIFS formula. After pasting it, test the dashboard by changing the filter selections. As you can see, it works perfectly. You'll notice that the average sales per order value in cell E6 remains unchanged. For now, we'll focus on making the main KPI calculations dynamic. Once all the primary KPI formulas are complete, we'll return and update the secondary calculations, such as average sales per order and profit margin, so they respond to the filters as well. Now, let's apply the same approach to the total sale. Go back to cell N9, where we temporarily created our SUMIFS formula. To calculate total sales, we only need to change the first argument. Replace the units column with the sales column. Everything else stays exactly the same because the remaining arguments contain our filter conditions. This formula now calculates total sales while responding to the selected quarter, category, and region filters. Test it by selecting different values from the drop-down lists. As you can see, the results update instantly. Now copy this formula and replace the existing SUM formula in the total sales KPI card at cell H5. Test it again. The total sales card is now fully interactive. Next, we'll create the total profit version. Edit the formula once more and change the first argument from the sales column to the profit column. Then copy the updated formula and replace the existing formula in cell K5. Test it using the filter dropdowns. The total profit card now updates automatically based on the selected filters. Our first 3 KPI cards are now fully dynamic. Now let's update the final KPI card. Instead of editing the formula in cell N5, we'll modify the helper formula that feeds it. The sales list in cell F10 is currently calculated with a SUMIF function. We'll replace it with SUMIFS so it can respond to the same dashboard filters. Delete the existing SUMIF formula. Then copy the SUMIFS formula from the total sales calculation and paste it into cell F10. This formula already includes the quarter, category, and region conditions. Now add one more criteria range and criteria pair. For the criteria range, select the Salesperson column from the data table. For the criteria, reference the spilled salesperson list in the left column. Now test the dashboard. Try different quarters, categories, and regions from the filter drop-down lists. Notice that every KPI card, including the top salesperson card, updates automatically to reflect the selected filters. Congratulations! You've successfully completed the first part of building your first dynamic and interactive Excel dashboard. From a single set of drop-down filters, every KPI now updates automatically, creating a dashboard that's both flexible and easy to use. Our SUMIFS formulas work well, but there's one problem. Every calculation repeats the same filtering logic, and we're not finished yet. We still need to calculate average sales per order, total orders, profit margin, and top salesperson. If we continue using SUMIFS, we'll have to repeat the same filter conditions in every formula. This makes our formulas longer, harder to maintain, and increases Excel's calculation workload. A better approach is to filter the data only once. We'll use the filter function to create a filtered version of the data table based on the selected drop-down values. Then, instead of repeatedly applying the same conditions, every KPI, table, and chart will simply use this filtered table as its data source. This results in cleaner, shorter, and more efficient formulas. Now let's see how the filter function can simplify everything. The filter function has two main arguments. The first argument is the array, the data you want to filter. In our case, that's the data table. The second argument is the include argument, a logical condition that tells Excel which rows to return. To understand how it works, let's start with a single condition. We'll filter the table using the selected quarter from the drop-down list in cell H1. When Q3 is selected, the formula returns only the rows where the quarter column equals Q3. However, if the drop-down is set to all, the formula returns a hashtag calc error. Why? Because filter tries to find rows where the quarter is literally all, and no such value exists in the table. Let's fix that. Just as we did with SUMIFS, we'll check whether the drop-down is blank or contains all. We'll modify our condition so that when all is selected, the filter function returns every row instead of looking for the word all in the quarter column. However, with our first attempt, Excel returns a hashtag value error when all is selected. When a specific quarter is selected, the formula works correctly and returns only the matching records. So, something is missing in our logic. Let's examine why this happens and how to adjust our condition for the filter function. To understand why, let's evaluate only the if expression. We'll place the if condition in another cell and see what it returns. When all is selected, the formula returns a single value, 1. When a specific quarter is selected, it returns a spilled array of true and false. One result for every row in the table. This is the problem. The filter function needs an array of true or false values with the same number of rows as the data being filtered. It needs one result for every row to decide whether that row should be included. A single value cannot tell filter which individual rows to return. Instead of using if, we'll combine our conditions using simple Boolean arithmetic, as shown on the screen. Here's how it works. Each comparison returns true or false, which Excel automatically treats as 1 or 0 during arithmetic. When all or a blank value is selected, the first or second condition is true, so every row evaluates to 1, causing filter to return the entire table. When a specific quarter is selected, only the rows matching that quarter evaluate to 1, while the remaining rows evaluate to 0. Now copy this condition into the filter formula. Test it by selecting different values from the quarter dropdown. As you can see, it works perfectly. Now we'll extend the same technique to the category and region filters. Start by copying the Boolean expression we created for the quarter filter. Before pasting it, type an asterisk, then paste the expression. Next, replace every H1 reference with K1 and change the quarter column reference to the category column. Now test the formula by selecting different categories from the drop-down list. You'll see that the filtered table updates immediately. Notice that we use two different operators. The plus sign acts like or. If any one of the conditions is true, the expression evaluates to 1, allowing that condition to pass. The asterisk acts like and. It requires both filter conditions to be true before a row is returned. In other words, a row must satisfy both the quarter and category conditions to appear in the filtered results. Now repeat the same process one last time for the region filter. Copy the Boolean expression, update the references to use cell N1 and the region column from the data table, and append it to the formula. Now test the dashboard by changing the filter selections. As you can see, the table updates instantly and displays only the matching records. This filtered table becomes the foundation of our dashboard. From this point on, we no longer need to repeat the same filter conditions in every KPI, chart, and summary table. Instead, we'll simply perform all our calculations on this filter table. Another advantage of this approach is that if we decide to add another filter in the future, we'll only need to update this single filter formula instead of modifying dozens of formulas throughout the dashboard. To identify each column, let's add the headers from the original table. Since the filter function returns only the data, we'll add the headers manually. Simply enter the formula shown on the screen, and Excel automatically returns the header row from the original data table. Now our filtered table has the same column headings, making it much easier to read and work with. There's just one final improvement. Although this formula works perfectly, you may notice that the same Boolean expression is repeated 3 times. To eliminate that repetition, we can combine the LET and LAMBDA functions to create a reusable condition. Here's what's happening. The LAMBDA function defines a reusable calculation called condition. It accepts 2 arguments. Call, the column to evaluate. Cell, the corresponding filter dropdown. Inside the LAMBDA, we place our Boolean expression only once. Then, whenever we need it, we simply call the condition function and pass the appropriate column and drop-down cell. The LET function stores this reusable LAMBDA, making the formula much shorter and easier to read. If you're not familiar with LET and LAMBDA, don't worry. You can continue using the previous formula. It works exactly the same. This version simply demonstrates how these modern Excel functions can make complex formulas cleaner, easier to maintain, and much more reusable. Now it's time to replace our long SUMIFS formulas with much simpler formulas based on the filter table. Double-click the units sold KPI card to edit its formula. Notice how long and complex the SUMIFS formula is. We'll replace it with a simple sum formula that reads directly from our filter table. However, there's one important thing to understand. Our filter table is a spill range, which is actually a dynamic array. Unlike an Excel table, we can't use structured references to access its columns. Instead, we'll use functions such as chooseCalls, chooseRows, or index to retrieve data from the array. For the units sold KPI, we need to sum the units column. To make column references easier, I've numbered each column above the filter table. This way, instead of counting columns every time, we can simply use the corresponding column number. Now for the magic. For testing, enter the formula showing on screen anywhere on the worksheet. The first argument points to the filtered table spill range. The second argument specifies which column to return. In this case, 9 represents the units column. The sum function then adds all the values in that column. Now test it by changing the filter selections at the top of the dashboard. Notice that the result matches the units sold KPI perfectly. Finally, copy this formula and replace the existing SUMIFS formula in the units sold KPI card. Now let's do the same for the remaining KPI cards. The total sales card is also using a long SUMIFS formula. Edit the formula and look at the filter table. The sales column is in position 11. This is exactly why we added the column numbers. They save us from counting columns every time we build a formula. Now use the same formula as before and simply change the column number from 9 to 11. Test it by changing the dashboard filters. The result matches the existing total sales value. Now replace the old SUMIFS formula in the KPI card with this new one. Next, update the total profit KPI. The profit column is in position 13. Once again, use the same formula and change the column number to 13. Test the result, then replace the existing SUMIFS formula in the total profit KPI card. Now, all 3 KPI cards use short, simple formulas while producing exactly the same results. Finally, let's update our last KPI card, Top Salesperson. We won't edit the formula inside the card itself. Instead, we'll update its helper table, which supplies the data for the card. Previously, this helper table used a SUMIFS formula with 4 conditions. The 3 dashboard filters plus the salesperson name. Now we can simplify it to a single SUMIFS formula because our filtered table already contains only the matching records. Here, the first index function returns the salesperson column from the filtered table. The second argument is our spilled list of unique salespeople. The final index function returns the sales column to be summed. Notice that we're using index instead of choose calls because SUMIFS expects a range-like array for its arguments, and index is a better fit for that purpose. Now test the dashboard again. Try different combinations of quarter, category, and region. Everything updates correctly, and our formulas are now much shorter, cleaner, and easier to maintain. Now copy the formula we created for testing and replace the existing formula in cell F10, the helper list used by the top salesperson KPI card. We've successfully updated the main calculations for all our KPI cards. Now it's time to update the secondary calculations. Let's start with average sales per order. If you look at the current formula, it divides the filtered total sales value in H5 by the number of orders in the original data table. This no longer gives the correct result because H5 is now filtered, while count still counts every order in the original table. We're mixing filtered data with unfiltered data. Instead, we need to count only the rows in our filtered table, since each row represents 1 order. Let's build the new formula on a blank area of the worksheet first. We'll keep the existing calculation, remove the count function, and replace it with a rows function. The rows function simply counts how many rows exist in the filtered spill range. Since each row represents 1 order, this gives us the correct number of filtered orders. Test the formula by changing the dashboard filters. You'll see the average updates correctly. Finally, replace the old formula in the units sold KPI card with this new one. Next, let's update the total orders calculation in cell H6 under the total sales KPI. The current formula counts the rows in the original data table. Since our dashboard now uses the filter table, this formula also needs to be updated. Simply replace the count function with rows and point it to the filtered table spill range. The rows function counts the number of rows in the filtered table, which is exactly the number of orders after the selected filters have been applied. Now the total orders value updates automatically whenever you change the dashboard filters. For the third KPI, profit margin, no changes are needed. It already calculates the percentage using the filtered total sales and total profit values, so it updates automatically whenever the filters change. The fourth KPI, top salesperson, is also complete because we already updated its helper calculations to use the filter table. At this point, all 4 KPI cards are fully dynamic. We've replaced long and repetitive SUMIFS formulas with a single filtered table, simplified our calculations, and updated every KPI to respond automatically to the dashboard filters. Now it's time to visualize that data. In the next section, we'll create dynamic charts that display sales by month, category, and region. Since these charts will use the same filtered table, they'll automatically update whenever the dashboard filters change. Now it's time to create the charts. First, let's make some room for them. Right now, the helper tables, data validation lists, and filtered table occupy the space where we want to place our charts. Insert a few blank rows below the KPI cards. Don't worry about breaking your formulas. Excel automatically adjusts all relative cell references when rows are inserted, so everything continues to work correctly. Now we have enough space to begin. Let's start with the sales by category chart. Before creating the chart, we need a small summary table. First, retrieve the list of categories using the unique function. You could also retrieve the categories from the filter table. Since the available categories remain the same in this example, either approach works. Next, calculate the total sales for each category using the filter table. As we discussed earlier, SUMIFS has 3 arguments. The first argument is the range to search for matches. Since we want to group the data by category, we return the category column from the filtered table using index. In our filtered table, category is column 7. The second argument is the criteria, our spilled list of categories in C9. The third argument is the sum range, which contains the values to add. Again, we use index to return the sales column, which is column 11 in the filtered table. Our summary table is now complete. Test it by changing the dashboard filters, and you'll see the totals update automatically. Now we're ready to create the chart. Select the summary table, go to the Insert tab, and choose a donut chart. Just like any standard Excel chart, it links to the summary table, so whenever the summary updates, the chart updates automatically. You can customize the appearance of the chart however you like. When the chart is selected, the Chart Design tab appears, where you can choose from a variety of built-in styles. You can also click any chart element to open the Format pane on the right, allowing you to customize the colors, background, borders, text, and many other formatting options. Give the chart the title Sales by Category, then resize and position it below the KPI cards. Since the summary table is only used as the chart's data source, we'll place the chart directly over it to keep the dashboard clean and save space. Now let's create our second chart, Sales by Month. Just like before, we'll start by creating a summary table. Since our data doesn't contain a separate month column, we'll extract the month from the order date column using the month function. The month function returns the month number from each date and unique removes duplicates values. Now we have a list of month numbers, but they're not necessarily in order. Let's wrap the formula with the sort function to arrange them in ascending order. Next, we'll calculate the total sales for each month. This formula is a little more advanced because we're working with date ranges instead of matching a single value. So, this time we'll use the SUMIFS function. The first argument is the sales column from our filter table. This is the column that SUMIFS adds to calculate the total sales for each month. Next, we specify the order date column as the criteria range. Now comes the interesting part. Our table doesn't contain a month column. We only have order date. So, instead of matching a month directly, we'll create a date range that represents each month. Our first condition, as shown on the screen, creates the first day of each month. The greater than or equal to operator tells SUMIFS to include all dates on or after that day. Now we add a second condition using the same order date column. This creates the first day of the next month. Using the less than operator excludes that date. So together these two conditions return every date within the selected month. Because I9 hashtag is a spill range of month numbers, SUMIFS also returns a spilled list of monthly sales. Optionally, we can also include profit in our monthly chart. To do this, we need one more column that calculates profit for each month. Simply copy the existing formula and paste it into the next column. Now edit the copied formula and change only the first argument, which currently points to the sales column. Replace the column number 11 with 13 because the profit column is in position 13 of our filter table. Now we have a summary table with 3 columns: month, sales, and profit, ready to create our monthly sales and profit chart. Go to the Insert tab and choose a clustered column chart from the chart group. Now we have a chart showing monthly sales and profit. With the chart selected, go to the Chart Design tab and click Select Data. The Select Data Source dialog box appears. Under Legend Entries, uncheck Month and click OK. We don't need the month series in the legend because it doesn't represent a value being compared. The months are only used as category labels along the horizontal axis. A cluster chart is a good choice here because it allows us to compare 2 values, sales and profit, side by side for each month, making the difference between them easier to see. Now resize the chart, place it in the center area below the KPI cards, and change the chart title to Sales by Month. We now have 2 dynamic charts on our dashboard. Try changing the filters at the top of the dashboard, and you'll see both charts update automatically based on the selected values. For the second chart, we've used 3 separate formulas to build the summary table. As you can see on the screen, the formulas work perfectly, but there's a problem. Notice how we're repeating the same calculations again and again. The filter table is referenced multiple times. The same date ranges are calculated twice, and we're maintaining 3 separate formulas instead of 1. This makes the worksheet harder to read, more difficult to maintain, and forces Excel to perform the same calculations repeatedly. Just as we optimized our KPI cards, we can optimize this summary table too. Instead of using 3 separate formulas, we'll combine everything into a single formula using LET and LAMBDA. The LET function stores values that are used repeatedly, so Excel calculates them only once. For example, we store the dates, sales, and profit columns in variables instead of calling index multiple times. Next, we calculate the list of months, along with the start and end date for each month, only once. Finally, HStack combines the 3 results, month, sales, and profit, into a single dynamic summary table. The result is exactly the same, but the formula is shorter, easier to understand, easier to maintain, and more efficient because repeated calculations are eliminated. Now let's test our optimized formula by creating a new chart. Insert another clustered column chart using the summary table generated by our new LET formula. Just like before, open Select Data from the Chart Design tab, remove Month from the Legend Entries, and click OK. Now place both charts side by side for comparison. Change the dashboard filters and compare the results. Both charts display the same values, but there is one important difference. When we select a quarter filter, the old chart still displays all available months on the axis, even though only the selected quarter's data is being shown. For example, if we select the third quarter, the chart still shows months 1 through 9, but only months 7, 8, and 9 contain data. The new chart behaves differently. It only displays the months included in the selected quarter. Why? Because the optimized formula retrieves the month list from the filter table. When a quarter filter is applied, the filtered table contains only the records for that quarter, so the unique function returns only those available months. The old formula retrieves months directly from the original data table, which always contains all months, regardless of the dashboard filters. For an interactive dashboard, showing only the relevant months provides a cleaner and more accurate view. Now update the title of the new chart delete the old chart and its summary table, and adjust the position of the remaining chart and summary table under the KPI cards. Our monthly chart is now fully dynamic. Next, we'll create our third chart, sales by region. Just like the previous charts, we'll first create a summary table that calculates total sales for each region. This time, instead of creating separate formulas, we'll use a single formula with the LET function. Here's how it works. First, we create a variable called region. It uses unique to extract each region from the filtered table. The index function returns column 3, which contains the region values. Next, we create a variable called sales. The SUMIFS function calculates the total sales for each region. The first index returns the region column to find matches. The second argument uses our unique region list as the criteria, and the final index returns column 11, which contains the sales values to add. Finally, HStack combines the region list and the calculated sales values into a 2-column summary table. Now we have a dynamic summary table ready for our chart. Click anywhere inside the summary table, go to the Insert tab, and insert a cluster bar chart. Change the chart title to Sales by Region. Place the chart on the right side of the dashboard. If necessary, right-click the chart and use Send to Back or Bring to Front to adjust its position relative to other dashboard elements. Finally, format the chart to match the dashboard style. Add an outer border to each chart and adjust the formatting as shown on the screen, or customize it according to your preferred design. Our dashboard is now fully functional, but let's give it a more polished, professional appearance with a few final formatting touches. Start by selecting the main value in each KPI card and make the font bold so the key figures stand out. Next, right-click the total sales value, choose Format Cells, select Currency, set the decimal places to 0, and click OK. The total sales KPI now displays the appropriate currency symbol. Repeat the same steps for the total profit KPI. Now, both KPI cards display their values in a consistent currency format. You can also refine the appearance of the charts by adjusting the border thickness, resizing the chart titles, and applying any additional formatting that matches your dashboard style. After these finishing touches, your dashboard has a clean, professional look, just like the one shown on the screen. Now let's move on to the next part of our dashboard. So far, we've created KPI cards and interactive charts, but we haven't built a showcase table yet. Scroll down on the dashboard sheet. We'll need a little more space, so insert a few blank rows below the charts. Don't worry, Excel automatically updates the cell references, so none of our formulas will break. Let's create a table that displays products ranked by sales, along with an inline bar chart that makes the comparison even easier to read. The table will contain 5 columns: product, units, sales, profit, and an inline bar chart. The products with the highest sales will appear at the top, while the lowest selling products will appear at the bottom. Looking at the columns we need, our task is straightforward. First, we'll group the data by product. Then we'll calculate the total units, sales, and profit for each product. Finally, we'll generate an inline bar chart based on the sales values. This sounds like a complex formula, but we'll simplify it using the LET function. LET allows us to store intermediate calculations in variables and reuse them throughout the formula instead of calculating the same thing repeatedly. This makes the formula shorter, easier to read, and more efficient. We'll start by defining 3 variables. The first variable, table, stores a reference to our filtered spill range. The second variable, prod_call, returns the product column from that table using index. The third variable, products, extracts the unique product names from prod_call. Notice how each variable builds on the previous one. Prod_call uses the table variable, and products uses prod_call. Now we have the first column of our table, products. Next, let's calculate the units column. Create a new variable called units and use the SUMIFS function. For the first argument, the range, we use prod_call because that's the column we'll search for matching products. For the second argument, the criteria, we use the products variable, which contains the unique product names. For the third argument, the sum range, we return the units column from the filtered table using index, which is column 9. Oh, look at the prod_call variable definition. We accidentally placed 8 in the second argument of the index function, so Excel interprets it as the row number instead of the column number. Let's fix that by leaving the row argument blank and placing 8 in the third argument. Now let's create the sales variable. Simply copy the SUMIFS formula from the units variable and change only the last argument. Instead of summing the units column, point it to column 11, which contains sales. Next, create the profit variable. Again, copy the same formula and change the last argument to column 13, which contains profit. Now let's see the result. Use the hstack function to combine all 4 variables into a single table. And there it is, our summary table. The calculations are correct, but the products aren't sorted yet. We want the highest selling products to appear at the top. To do that, simply wrap the hstack function with sort. We'll sort by the third column, which contains sales, and use -1 to sort in descending order. Now the products are ranked from the highest sales to the lowest. There's just one thing missing, our inline bar chart for each product. Let's create it. We'll continue using the same LET formula by adding 2 more variables. First, create a variable named max_sales and use the max function on the sales variable to retrieve the highest sales value. Our idea is simple. We'll compare each product sales with the highest sales value and use that ratio to draw a proportional bar. Next, create another variable named bars. This variable will generate the inline bar chart. We'll use the map function to process each value in the sales array, and inside it use a lambda function. The lambda function defines a variable named S, which represents the current sales value being processed by map. Inside the lambda, use the rept function. The first argument is the full block character, which will be repeated to draw the bar. The second argument determines how many blocks to display. We divide the current sales value S by max_sales to calculate its relative size, then multiply the result by 50 to control the maximum bar length. Feel free to increase or decrease this value, depending on how wide you want the bars to appear. Finally, add the bars variable to the end of the hstack function, right after the profit column. Press Enter, and our inline bar chart is ready. Now test the dashboard by changing the filters at the top. You'll see that both the summary table and the inline bar chart update automatically, giving us a clean, dynamic product performance table. If you noticed, there is a small visibility issue. The product names are not fully visible because the next column, units, is blocking the remaining text. Let's fix this. First, copy the complete formula and paste it somewhere else temporarily so we don't lose our original calculation. Now edit the original formula and remove everything except the unique product list. With only the product names displayed, Excel allows the text to overflow into the empty space, so the full product names are now visible. To keep our complete table intact, we'll move the remaining table columns 1 position to the right. Copy and paste the table headings 1 column further, leaving a blank column after the product column. This empty space allows the product names to display completely while keeping the table layout clean. Next, edit the formula that we pasted temporarily. This time, modify the products variable. Instead of retrieving the unique product list from prod_call, Simply reference the product list that's already displayed in B26. Since the product names already exist in the first column, remove the product's variable from the HStack function. The formula now returns exactly the same results as before, except the product column. Move this updated formula under the units heading so it starts from the second column. Now the table looks much cleaner, and the product names are displayed correctly. Let's finish by formatting the table. Make the column headings bold. Select the row above the table. From columns B to R, set the background color to black, and change the font color to white. With those cells still selected, open the Format Cells dialog box. Go to the Alignment tab, choose Center Across Selection, and click OK. Type Sales by Products, increase the font size, and adjust the row height so the title stands out. Finally, select the entire table, including the title and headings, and apply a thick outside border. Our Sales by Products table, with its built-in inline bar chart, now has a clean, professional look and makes an excellent addition to the dashboard. Now test the table by changing the dashboard filters. At first glance, everything looks great, but there's still one problem. Did you notice it? The products are no longer sorted correctly. Why does this happen? Because we're now using two separate formulas. The first formula displays only the product names. The second formula generates the rest of the table and uses the sort function to sort the data by the sales column. Since the product column is no longer part of the sorted array, it stays in its original order while the remaining columns are sorted independently. As a result, the product names no longer match the corresponding units, sales, and profit values. So, let's fix this with a better approach, one that keeps the entire table as a single dynamic spill range while still allowing the full product names to be displayed. Unfortunately, we can't use merge cells because spill ranges cannot expand into merge cells, and Excel will return error. Let's look at a different solution. First, we'll restore our table to its original state. Edit the second formula and add the product's variable back into the HStack function. Delete the temporary product formula. Move the formula back to the first column so the entire table spills from a single formula again. At this point, the table is back to its original layout. Now edit the formula once more and wrap the HStack function with sort, sorting by the third column, which contains sales in descending order. Now our sorting is working correctly again. We're back to where we started, but this time we're ready to solve the product name display issue without breaking the sorting. Here's the trick. Instead of using two independent formulas, we'll create a second formula that simply mirrors the product column from the main spilled table. To demonstrate this, temporarily move the main table a few columns to the right so you can see what's happening. The entire spilled table now starts in E26, including the product column. Under the product heading, enter a choosecalls formula. In the first argument, reference the spilled table E26 hashtag. In the second argument, specify one to return only the first column. The formula now displays only the product column from the spilled table. In other words, it's simply mirroring the product column. I've now moved the main spilled table from E26 to D26, so update the reference in the mirror formula accordingly. At this point, you'll notice two product columns. One belongs to the main spilled table, and the other is the mirrored product column under our product heading. The difference is that the mirrored column can display the full product names because it can overflow into the empty column beside it. Now comes the final trick. Select the product column from the main spilled table and change its font color to white so it blends into the background. The data is still there. It has simply become invisible. The mirrored product column now appears to be the only visible product column, while the main spilled table remains intact. This means the sort function continues to control the entire table as a single unit. Now, when you change the dashboard filters, the products remain correctly sorted and perfectly aligned with their units, sales, profit, and inline bar chart, something our previous two-formula approach couldn't guarantee. Now the table looks exactly as we wanted. Full product names, correct sorting, and a completely dynamic layout. Now let's create another showcase table. This time, sales by salesperson. First, we need some more space for this table. Insert a few blank rows below the existing table. Again, don't worry about any formula references breaking. Excel automatically adjusts the references when rows are inserted. Now we'll reuse the formula from our sales by products table. The logic is almost identical. We only need to change the column we group by, update some variable names, and remove any columns that are not needed for this table. Paste the formula, and you'll notice it is still showing the product-based summary. Now look at our filtered table. The salesperson column is located at position 6. Edit the formula and change the index reference in the prod_call variable from column 8 to column 6. Press Enter, and this small change transforms the entire table. The same formula now generates a summary based on salesperson instead of product. This is the power of the LET function. We only change one variable, and every calculation that depends on it updates automatically. However, our variable names are still based on the product table. To keep the formula clear and easier to maintain, let's rename the variables. Replace prod_call with a more general name, call. Replace the products variable with Sperson because it now represents the unique salesperson list. Update the variables everywhere in the formula and test it. The formula should continue working exactly as before. Now let's customize the output. Add headings for each column. For this table, we don't need the profit column, so edit the formula and remove it from the final hstack function. Finally, format the table. Make the headings bold. Apply the same formatting style we use for the product table, including a thick outside border. Add a main heading, Sales by Salesperson. Apply a black background with white text to match the dashboard style. Now our Sales by Salesperson table looks clean and professional. Test it by changing the dashboard filters at the top. The table updates dynamically and responds perfectly to every filter selection. Let's add one more visual to our dashboard, a chart that shows how customers are paying. This chart will display sales distribution by payment method. First, we need a summary table that calculates total sales for each payment method. Create two headings. Payment method, sales. We'll reuse the same LET formula that we created earlier and modify it for this new summary table. Copy the existing formula and start editing. The first change is the column we use for grouping. Currently, the formula is based on the salesperson column. In our filter table, the payment method column is located at position 14, so replace the existing column reference with 14. Next, rename the variables to match the new purpose of this table. For example, replace the salesperson-related variable names with payment so the formula remains easy to understand. This time, we don't need all the calculations from our previous table. Remove the additional SUMIFS calculations and variables that are not required, such as max_sales variable and the inline bar chart calculation. Remove the sort function as well. Finally, update the hstack function. It should contain only two variables. The payment variable, which contains the payment methods. The sales variable, which contains the total sales values. Now our summary table is complete, showing two columns, payment method and sales. Let's create the chart. Click anywhere inside the summary table, go to the Insert tab, and choose a 3D pie chart. Resize the chart and change its title to Payment Methods. If you want a different appearance, go to the Chart Design tab and choose another style from the chart gallery. You can also double-click any area of the chart to open the Format Chart area pane on the right side of Excel, where you can customize additional options such as fill, border, effects, and other formatting settings. Once you're satisfied with the design, place the chart over its summary table and resize it to match the width of the other dashboard elements. Finally, apply a thick border around the chart to keep the same visual style as our other charts. And that's it. Our dashboard is now almost complete. The best part is that you can still extend it. For example, if you want to add more filters at the top, you only need to update the filter formula that creates the filtered table. Every KPI, chart, and summary table will automatically follow the new filter because they all depend on this single filter dataset. You don't need to edit dozens of formulas across the dashboard. This makes the dashboard highly dynamic, interactive, and easy to maintain. Throughout this tutorial, we built every part step by step, so even beginners can understand how each formula, calculation, and dashboard element works. Now, let's add one final touch to give our dashboard a more modern look. Scroll back to the top of the dashboard. Go to the Insert tab, open the Shapes drop-down, and choose the rounded rectangle shape. Draw and resize it to match the size of KPI card. Next, open the Shape Fill menu and choose No Fill, so the shape becomes transparent and the KPI values remain visible. Now select each KPI card and remove its existing border by choosing No Border from the Home tab. With the old borders removed, copy the rounded rectangle and paste it 3 more times so all 4 KPI cards have identical rounded borders. Position one rounded rectangle over each KPI card and align them neatly. With just this small design change, our dashboard instantly looks cleaner, more modern, and much more professional. You can further enhance your dashboard by experimenting with different formatting options. For example, I'm changing the font color of the inline bar charts, and even this small modification makes the dashboard look much more polished and visually appealing. That brings us to the end of this tutorial. In this video, I tried to explain every step with beginners in mind, showing not just what to do, but why we do it. Along the way, we used practical, real-world applications of Excel functions such as filter, SUMIFS, LET, LAMBDA, map, index, choose calls, unique, sort, and many others to build a fully dynamic and interactive dashboard from scratch. I hope you found this tutorial helpful and learned something new. If you enjoyed the video, please give it a like, subscribe to the channel, and share it with anyone who wants to improve their Excel skills. I'll also provide the completed workbook so you can follow along, explore the formulas, and practice everything we've covered. Thank you so much for watching, and I'll see you in the next video.